If I was like dancing or something like paintball or something, why warehouses not you got like arcade games like Pac-Man. I was like, yeah, I'm not this the whole thing. I'm not part of that. Keep it back to the fucking thing. But you get a server or backup shop. Yeah, that's the Americano burgers. My favorite burger country.
The cheesecake, that's
Yeah.
probably not all I paid that for.
Most people go for a second.
If it was doing it, I'm gonna do it.
Oh yeah. Maybe like every 2 months. Okay, go there for a week.
That's what I do. My wife doesn't move for dessert. And it's like, hey, you know, just get something here too. Because I'm not gonna eat lunch and I drive out just for dessert now. But leaving the house, it's gonna be a whole routine when we get drunk.
I would just go to a buffet.
I would, but it's always fun.
Golden Corral. Or,
She doesn't. Feels like it's been a while. Because last year was just the house, we didn't do anything.
oh yeah.
It feels like it's been a while since we've done something.
It felt like refreshing.
We started probabilities.
Yeah, we did.
Yeah, so we're continuing with that. The probability is just basic. Right, we introduced the rules, or not, I'm sorry, we introduced the definition, right? What a probability is, and just basic calculations. Compound event. An event formed by combining two or more events. Now, we've actually looked at compound events. We're doing the coin flip and dice roll. Heads and two, that's a compound event. Now, events are sets. Right? Three operations on sets. Three basic ones at least. We have the union, the intersection, and the complement. So of course, we have probabilities for those. We're looking first at OR, which is a union. Probability of P or B means it's the probability that A occurs or probability that B occurs, or both. And so in mathematics, or is always inclusive, not exclusive. I'm sure you're all familiar with Venn diagrams. When first learning about sets and their operations, it's convenient to think of it in terms of a Venn diagram. This would be union. So that's A union with B. So it's everything that's in either A or B. Then we also have the intersection. A and B, it's probably that both A and B occur simultaneously. Intersection of two sets. It's all the elements that they have in common. And so in terms of Venn diagrams, that's where your sets overlap. guess the complement will occur later, so it's not really a compound event. Contingency table is just a table that shows the distribution of one variable in the rows and another in the columns. So, probability that A or B occurs. This is the general addition rule. It's the probability of A plus the probability of B minus the probability of A and B. Well, we can, of course, rearrange this and write probability of A and B as probability of A plus probability of B minus probability of A or B. We say that two events are mutually exclusive if it is impossible for both events to occur. Right? That is, the probability of A and B is 0, or their intersection is empty. Well, if two events are mutually exclusive, that simplifies our probability formula, right? Now, probability of A and B is 0. So in that case, we would just say the probability of A or B is probability of A plus probability of B. There's the complement. A is any event. The complement of A is the event that A does not occur. Commonly denoted as A raised to a C power. There is another notation for complements. I know why it's not used. But in set theory, it's typically represented as a bar. So if I use that notation instead, that's what I mean. I know why it's not used in statistics, because A bar typically means the mean of A. But we'll try to remember the A to the C power mode if I slip up. That's the notation. Well, notice, right, that A is either going to occur or not occur, right? Has to be one or the other. So the probability of A or A complement would have to be 1, wouldn't it? Because it's guaranteed to happen. You can then rearrange that to find the probability of A complement. 1 minus probability of A. A and A complement, are they mutually exclusive? Remember, it needs to be mutually exclusive. They both can't occur simultaneously. So are A and A complement mutually exclusive? Look outside in the morning. Can it be both raining and not raining? They have to be mutually exclusive. Right? An event can't both happen and not happen simultaneously. Unless you're quantum mechanics, but that's different. 330 subjects, I like that, subjects. I'm calling people down for subjects. Asked for their age and streaming preference. Results are given in the table. That is a contingency table. One person, yeah, that's going to be hard to see. Of course, my formatting is off too. One person is selected at random. We want to calculate the following probabilities. Don't know why that is off. Looks better. This. First, those, and next one. So start here. Probability that the randomly selected individual prefers streaming series. So you look at the table, and you go, okay, how many individuals preferred streaming series? 126. Out of how many total? So that's your probability, and that was fairly straightforward. I believe that's about 0.382. You can just double check that. Probability that the selected individual is under 25. And this is a pretty straightforward one. How many individuals are under 25? 120 out of how many total? That should be about 0.364. Probability that the selected individual is 45 plus or prefers streaming sports. So when dealing with probabilities, two ways you can represent or. That's the logical symbol for or. But since we're dealing with sets, we may also use union. Which is the same thing, means or, just in set notation. This way. General addition rule. Again, wait a minute. No, that's right again. Two notations for the intersection or and. The logical connector or the set connector. Now here's the thing. All those probabilities are going to have the same denominator, right? So we could just write it all over a single denominator. For now, just keep the separate fractions. So we want the probability of 45 plus. How many are 45 plus? Probability that they prefer streaming sports. How many total prefer streaming sports? But here's the thing. Just stopping there double counts. We've counted those that are 45 plus and prefer streaming sports twice. That's why we have to subtract the intersection. How many with 45 plus and prefer streaming sports? What is it? 31. Now you should form that arithmetic. $90 plus 75, 165, minus 31, 134, right? That is the probability. Which is about 3.06. Easy tables getting right. Probability that the selected individual is between 25 and 44 and prefers streaming movies. Again, this one is actually really straightforward, given the fact that we have the contingency table. 25 to 44, movies. 36, right? $36 out of 330. And finally, probability of not movies. So the probability that they prefer not to stream movies. And so again, I could use two notations. I prefer that notation. I could also just do complement, right? Not movies. But that is the logical connector for not. There are two ways you could go about this. Not movies. So you could sum up the total of who prefers series, sports, or other, right? Or go, okay, well, the probability that the person prefers to stream movies or not movies is 1, right? It's going to be one or the other. So why not just do 1 minus the probability that they prefer to stream movies? How many people prefer to stream movies? You should be able to do this quickly. What is that difference? Roll 0.697. Very useful. Generally speaking, if you ever want to calculate the probability of a complement, that's what you're going to want to do. So suppose we have those probabilities, right? So they give us the probability of A, probability of B, and the probability of their intersection. We want a probability of their union. What's the general addition rule?
Probability of A plus probability of B minus probability of
A what?
and B.
So just real quick. Rearranging those formulas, we could write this too, right? Probability of their union plus probability of their intersection is just the sum of the probabilities. Not sure when that's going to be useful, but it's interesting. And these are cases we like because they gave us directly what the probabilities are. What is 35 and 52? What is it? 87, and now 87 minus 21. 66, right?
Yes.
Oh. Same kind of idea. Just rearrange the formula. .48 plus .41 minus .70, right? What is 48 and 41? Now subtract 70.
Or, sorry, 19.
There's your probability, 0.19. Now, real quick, what are two things we know about probabilities? What values do probabilities have to be between? Actually, I guess it's the only one we don't need. What's the smallest a probability can be? What's the largest it can be? What'd you say? Are you giving to me in percentage? 1. 100%. I am not very forgiving on probabilities if you get a value outside of that. So if you did this calculation and let's say you got negative 0.19 and you just left it like that on a test, you get 0 credit. Because you should know something's wrong. Now if you write, you leave negative 0.19, but then you write, this is clearly wrong, but I don't know what I did wrong, I will give you partial credit for at least realizing that it's wrong. So that's a very important property to keep in mind. Always between 0 and 1. Probability of A is 0.40, probability of B is 0.30, and the probability of their union is 0.70. Are these two events mutually exclusive? What does it mean to be mutually exclusive? 1 is equal to 0. Yeah, that would be 0. That's not the actual definition. Yeah, that's correct. Right, they can't occur simultaneously, so the probability of the intersection has to be 0. Two ways then you could calculate, you could determine this. Calculate their probability of the intersection, or check that. Probability of their union has to be the sum of the probabilities. They both say the same thing. It's probably easier to check that latter condition, right? Probability of A plus probability of B. What's 40 plus 30? What's 40 plus 30? Which was the union. So they're mutually exclusive. Okay. A and B cannot occur simultaneously. So let A be the event that's sunny out, and let B be the event that it's raining out. Are A and B mutually exclusive? No. It's very rare, but you can have sunshine and rain. Snow and rain, I think that's also possible. It can be both snowing and raining at the same time.
There's a term for that. I don't remember.
Well, I don't know about that, but there's a term if there's snow and thunder. It's called thunder snow. Again, very rare, but it is possible. It does happen. Just why they use thunder, I don't know. Thunder itself isn't really a phenomenon. Lightning is the phenomenon. Thunder is just the correct of the lightning. Same question. Are these two events mutually exclusive? Why not? I never understood this. It's 12:37. You're now telling me about the event at 12 o'clock.
Because addiction with A has probability is 80 and probability A or B because it has to 0.72.
Therefore, we are not mutually exclusive. And again, on a test, it's not good enough just to tell me that they are or they aren't. You have to justify it. Your justification is that. Right? P of A plus P of B does not equal P of A over B. And show that calculation. It's 12:40. So we want to find probability and D complement. complements, it's just 1 minus the probability of the event occurring. $100 minus 28. Minus 28. $72. Make it easy. 100 minus 30, 70. Add 2. 100 minus 64. Bless you.
Thank you.
Yeah, that time of year. I was bedridden all weekend. Because of the stupid allergies. At a service center, let B be the event that needs battery, let T be the event needs tires. Suppose that the probability of needing a battery is 0.22, probability of needing tires is 0.18, and the probability that you need both a battery and tires is 0.07. Find the probability the car needs a battery or needs tires, and then probability that the car does not need a battery. We put battery union with tires. Try and make it less like you and more like a compound. How would you find that probability? So B union with T.
Probability of being the value of T minus A and B.
B was what? T was what? And their intersection. Whose probability of their intersection? No. 22 and 18. $40, right? Minus 7. There's your probability. Probability it does not need a battery is B complement, right? No, that's going to be 1 minus the probability of it needing a battery. $100 minus 22. Somebody. Easy, right? Why is probability so hard? Little more. Pretty sure even on the test, I don't actually require you to count. So it's all simple probabilities. So there's a fun question of, you have 10 people running for like student president or whatever. And say it's split evenly, 5 males, 5 females, and I can go, what's the probability that the president's female? The actual math, you have to count how many total possible combinations there are. Which gets really interesting. We have a box that has 10 numbered tags. Tags 1, 3, 4, 7, and 10 are blue. Draw one tag at random. What's the probability that it is blue? What is it? I'll just leave these fractions this time. 1/2, right? How'd you get it? Five of them are blue, right? So 5 out of 10. What is the probability that it is odd? Hmm? How'd you get 7? It's 5 out of 10. There are 5 odds, right? One, 3, 5, 7, 9 are your odds. That's 5 of them. What is the probability of blue or odd? How'd you get 7? How'd you get 7?
I just saw that there's 3 odd numbers and the ones that are blue, and there's 5 odd numbers, so subtract the 3 that are already blue. It's 2 plus the 5 blue.
And using the addition rule, which is the exact same thing. Probability of it being blue, 5 out of 10. Probability of odd, 5 out of 10. How many are both blue and odd? You have 3 of them, so you subtract the 3. 7/10. Now, probability of not blue. Hmm? How'd you get it? What was it?
So half of the 10 is blue and half of the 10 is.
5 of them are blue, so 1 minus 5/10. 1 minus the probability of it being blue. Easy, right? I think I have the right section. Section K and L is this week, so those numbers will be due. Second test is up this week. It'll be due next Thursday. It'll cover regression and the probabilities. So that's what, section I, J, K, and L, 4 sections. So that should be a pretty easy test. It's mostly probabilities. Second AI assignment is up. It'll be due 2 weeks from today. It's fairly straightforward. It's just going to ask you to calculate some probabilities, and then you have to verify it. See how good it is at calculating probabilities. I'm almost done grading the midterms. I'm trying to remember. I think I have 1 question left, maybe 2 left to grade. No, 5. I have to give 2 Calc 1 midterms tomorrow. So I'll be grading them. If I don't get to them at all today, it'll be tomorrow. So they will be done tomorrow. Supposed to give the midterm yesterday, but little issues prevented that. Hmm? The test is taken, it's online, just like the first one.
How would the midterm so looking so far?
Based off of what I've seen so far, I don't remember. So. There may be an Excel part for the linear regression. The probabilities will not require Excel.
Okay.
I can't remember. I didn't include a file for the second test. So I don't recall if the regression was going to require you to put it into Excel.
Okay.
I can't remember. I wrote it so long ago. And I believe I have the second group assignment set to go up next week. Not be due, go up. Yeah, so it's not available. I think I have it set to go available next week. So let's practice this stuff, get into your groups.